Hello and welcome to Train Signal. You are watching a lesson about Linux file systems. The first Linux operating system that I decided to use full-time was Ubuntu. My laptop at that time was struggling under the stress of Windows Vista and in terrible need of relief. The first time I installed Ubuntu, I downloaded the image, burned it onto a CD, and pretty much let the install take care of things for me from there. But as we've learned, it's often a good idea to segment your hard drive, putting directories like home and swap on their own partition. So I backed up my data and bravely started all over again. During our Linux installation lesson, we touched on the subject of partitions. In this lesson, we'll cover how to create partitions and what the associated file system types are. And as all file systems require a little loving care, we'll talk about how to do some maintenance and integrity tasks. Finally, we'll review how to mount and unmount a file system. Let's get started with how to create partitions and file systems. Normally, Linux will guide you through the partitioning process during installation, but if you add a new hard disk, or if you're like me and you just like to start over again, you'll need to be familiar with Linux's tools. First, you'll need to create the partition with fdisk, also known as fixed disk, then prepare it for use. Fdisk works on master boot record disks, and the command is fdisk space name of the device. Once you enter the utility, you can type P to display the current partition table. And at the fdisk prompt, you can use these commands. N creates a new partition. D deletes a partition. T will change the partition type code. L will list the most common type codes. A makes the disk bootable. And M is for help. To exit the program, you type Q, which will exit without saving, or W, which will write the changes to disk and then exit. You can also display your partition information without entering the utility by typing fdisk space -L. Let's take a look at that. Now again, another thing to reiterate about fdisk is that you won't be able to make changes to a mounted file system, but we can take a look at what we've already got configured. So let's go ahead and type in SU first to gain root privileges. Type in your password and hit enter. Now we're going to type in fdisk space -L, and that's the list option if you recall. Then we're going to enter the device name, which is dev SDA. It'll usually either be SDA or SDB. And go ahead and hit enter. And we can see the information here about how we currently have the disk configured and the hard disk layout. We have heads, sectors and tracks, cylinder information. Then we have our devices here. We've got SDA1, which is the boot device. We have where it starts and ends, an ID, 83, and we know that it's a Linux system. Then we've got SDA2. Again, we have the start and end information. And then we have here that it's a Linux virtual machine. When you prepare a partition for use, it's referred to as making or formatting the file system. And there are several file systems to choose from. The first is ext2fs, also known as ext2, and the extended file system was popular during the 90s, but nowadays the second extended file system is used mostly for small boot partitions or small removable disks. ext3fs, or ext3, is simply ext2 with journaling added. This allows for quicker recovery from system crashes. ext4fs, or ext4, is used mostly with newer Linux releases, and particularly systems with very large disks or files also use this file system. RiserFS, also known as Riser, is a journaling file system, and it's good for systems with large amounts of small files. JFS is developed by IBM for its AIX operating system and later for OS/2. It's mostly useful if you're already familiar with either of those operating systems. XFS was created by Silicon Graphics for their IRIX operating system, but the code was later donated to Linux, and some features still aren't well supported under Linux. BTRFS, also known as ButterFS, is very fast and it's able to handle large disks and files. It was inspired by Sun's zettabyte file system. Right now, though, this is still considered experimental. VFAT is used to add support for Windows-type long file names. FAT, or File Allocation Table, is the only file system supported by Windows 9 and DOS. It's best suited for exchanging data on removable disks. NTFS, or New Technology File System, is used by Windows NT and up to Windows 7, but it's fully supported by Linux. As of kernel 2.6.x, Linux can read and overwrite files on this file system, but it can't write new files to this partition. HFS and HFS Plus are Apple's hierarchical file system. It has full read-write Linux support, but it's not quite as reliable as FAT. ISO 9660 is a standard CD-ROM file system, and it has 3 levels, with levels 2 and 3 adding support for longer file names. Rockridge extensions enable support for Unix-type long file names, permissions, symbolic links, and more. Joliet is similar to Rockridge, but it was created by Microsoft for use with Windows. Linux supports Joliet as part of the ISO 9660 driver. UDF, or Universal Disk Format, is the next generation file system for optical disks like DVD-ROMs. Read-write support is still immature, though. As a general rule of thumb, use a Linux file system. Administrators will most commonly find themselves working with ext3, ext4, or RiserFS. Let's take a look at how to create a file system next. Once you've decided on the type of file system you want to use, it's time to create it. You can do so with the mkfs command. The syntax is mkfs space file system type. And the type, of course, is one of the types that we reviewed on the previous slide. So for example, we could type in mkfs space -t space RiserFS space dev HDA5, which will install the Riser file system on HDA5. And the -c option will perform a check for bad blocks during the process. If you want to create a swap partition, you use the mkswap command. And the syntax is relatively simple as well. It's mkswap space device name. Then you'll need to initialize or activate it with the swap on command, which is swap on space device. And you see a couple of examples there on the screen. Next, let's talk about file system tuning. One of the duties you'll perform as an administrator is system tuning. In most instances, you run maintenance utilities when the file system is unmounted. To first assess information about your file system, you can use the dumpe2fs command. The syntax is dumpe2fs space options space device. The most commonly used option is -h, which will only display superblock info. Since this is one command that you can run on a mounted file system, let's take a quick look at that. The output from the fdisk command showed us that we had 2 devices here, and we'll use one of those to check our file system. From the prompt, let's type in dumpe2fs -h space /dev/sda2, which, as we can see, is, we're going to do 1, so we can look at our main Linux partition. And we hit enter. We can scroll up and take a look at the information provided. You can see the OS type, inode and block information, free blocks, and even journaling information. The XFS file system has a similar command, but actually requires the file system be mounted. That command is xfs_info space device name. You can also use a mount point like home. To modify the parameters reported, you use the tune2fs command. The syntax is tune2fs space options space device. The options are -C, which mounts the device, -I says to adjust the time between checks, -J adds a journal, -M space % sets reverse blocks used by root, -L and -U obtain the file system's label and universally unique identifier. The uppercase L and U changes the labels respectively. And if you use the XFS file system again, the XFS_admin is kind of equivalent to tune2fs. Next, let's take a look at the debugfs command. If you need to modify file system features, you use the debugfs command. The syntax is debugfs space device name. This will launch the program, and you'll see a prompt that just says debugfs followed by a colon. These commands can be used with the program. The first is show_super_stats or stats-display file system superblock info, and this is similar to dump2fs. Undelete inode name undeletes a file where inode is the inode number of the file and name is the file name you want to give it. Write internal -file space external -f extract a file. Write internal -file space external -f extracts a file, where internal file is the name of the file in the file system and external file is a file name on your main Linux system. cd, ln, and rm are all usable with this command as well, and that's change directory, link, and delete. List_request or LR, help, or question mark are all used to get help. Quit exits the program. Next, we'll review some other file system maintenance tools. With an older file system like ext2, if your system crashes, rebooting the operating system will automatically launch a hard disk check. And depending on the size of your hard disk, this process could take some time. So if you have users anxiously waiting to get back onto their systems, this could quickly become a problem. Journaling file systems changed all of this. A journal is used to describe pending operations. So prior writing data to the disk, Linux describes what it's going to do in a journal. So in the event of a crash, the system can check the journal and only do a system check on the data it contains. It can then roll back any changes or do whatever is necessary to ensure disk consistency. If you recall, Linux's journaling file systems are ext3, ext4, riserfs, xfs, and jfs. Another job you're likely to perform is checking the file system for errors. These errors could be the result of many things: bugs, power failures, or other hardware issues. The primary tool is called FSCK, but it's the front end to another tool that's called E2FSCK, which is the tool emphasized on the Linux Plus objectives. For the XFS file system, similar tools are XFS_check and XFS_repair. The syntax for FSCK looks a little intimidating, but we'll go through all the options. It's FSCK, and the options are -S, A, C, B, R, T, N, P, space -T, file system type, -FSCK options, space file system. -C says to indicate the progress. -V says to make the output verbose. -N says to display without action, and that's capital N. -t says to force the file system type. -a or -p are for automatic checks. -r does an interactive check, and -f forces a full file system check. Let's move on and talk about monitoring disk usage. To monitor your disk usage, ensuring you don't run out of space, you can use the df and du commands. The syntax for df is df space options space files. The du command will display the same information, but by directory. The syntax is also du space options space directories. The options for both commands are the same. The first is -A or --all reports individual files. -C or --total adds a grand total to the end of the output. -H or --human scales and labels units. -L or --count links counts hard links independently. --max -depth equals n limits the report to n levels, where n is the number of levels you'd like to limit to. --summarize limits the report to those files and directories that you specify on the command line. And -x or --1-file-system limits the report to the current file system. Let's go back to a terminal window and try out both of these commands. Okay, to show how the command works for a regular user, let's first exit from root privileges, and then let's go ahead and clear the screen. Now to take a look at disk use by partition, let's type in df and hit enter. And we can see here in the first column we have the file system. We've got some block information, the amount of space used, the amount that's available, the percentage that's used, and the mount point. So for example, for our device SDA1, we've got some block information here. We've got the amount of space that's used and available. We know that 14% of that is used and that it's mounted at boot. Now let's take a look at disk usage by directory with the du command. First, let's type in du with no options. Hit enter. And we can see a list of all of the directories on the system and the space being used. I have a pretty long list here. So say we wanted to look at disk usage for an individual user for their home directory. To do that, we would type in du space -s space home, and we're going to need to put in a user. I'm going to put in myself. And let's hit enter. And we can see for the user V. Henry for her home directory, this is the amount of space that's being used. You can either mount a file system on a one-time basis using the mount command, or make the change permanent in the etc fstab file. The syntax for mount is as follows. Mount, followed by the parameters that we'll talk about in just a second, -t space file type, -o for options, followed by device, followed by mount point. The parameters are -a, which says to mount all file systems listed in etc fstab, -r says to mount in read-only mode, -v says to make the output verbose and provides comments on operations as they occur, -w says to mount for both read and write operations, -t fs type specifies the file system type, -L and -U mount with the specified label or UUID. Device is the device file name associated with the partition or disk. And finally, the mount point is the directory to which the device's content should be attached. If you need to add file system specific options, you can do so with the -o parameter we talked about on the previous screen, or you can do it by changing the etc fstab file. There are 17 options, and you can review those on the Mount man page for more detail. But they are defaults, loop, auto or no auto, user or no user, users, owner, remount, RO, RW, UID equals the specified value, GID equals value, UMask equals value, DMask equals value, FMask equals value, CONV equals code, no rock, and no Joliet. As we've talked about before, most of your system maintenance tasks will need to be performed on an unmounted file system. To unmount your file system, you use the umount command. And if you notice there is no N, it's UMOUNT. The syntax is umount space parameters space file system type space device, space mount point. The parameters are -A, which says to mount all the file systems in etc fs tab. -F forces the unmount action. -R says if the file system can't be unmounted, remount it in read-only mode. -T specifies the file type, and you must specify either the device or the mount point. With manually mounting file systems covered, we'll answer the question of how to permanently mount a file system on the next slide. To permanently mount a file system, you edit the etc fs tab file. On the screen, you can see the contents of that file, but let's take a look at a live version. And let's type in clear our screen. Now let's type in cat to display the contents of a file, space etc /fs tab, and hit enter. And we can see the contents of that file. The first column lists the device, as you can see here, followed by the mount point, the file system type, any mount options, backup operations, and the file system check order. And that concludes our lesson on Linux file systems. Let's review what we've learned on the next slide. Learning to create, modify, and maintain file systems and partitions are not only requirements for the Linux Plus certification exam, but also key components of a system administrator's duties. And in fact, regular users will even benefit from being able to troubleshoot and maintain their own systems. Doing so will earn you much praise from your IT departments. In this lesson, we covered creating partitions and file systems. We learned about the various types of file systems and under what circumstance each of them might be used. We talked about the essential task of tuning and maintaining the file system. And finally, we covered mounting and unmounting your file systems. Thank you for watching, and I'll see you in the next lesson.